Okay, hi everybody. Let me adjust this microphone. All right, so some announcements I have taken back the room. Sorry, guys. Okay. Okay. So I've made a checklist. If you want to keep track of all the things that are going on, you don't have to use this checklist, but it exists if you want to know all the things that are due for the first 5 weeks. I hope this is helpful to help you organize. If you're someone like myself who needs deadlines to get things done, here are your deadlines. All right. Homework 0A is due today. Now, it's the beginning of the class. People are still kind of joining. I did want to note, all right, guys, I got to take the room back. I know there's a lot to chat about. I believe in you. We can listen. All right. Almost there. So close. All right. So on Homework 0A, you might have noticed there are these practice it links that are not quite all the way gone. I should have caught this. I didn't look at this before the semester started, and it was only pretty, like right before we got started that we realized that we had left in this the site practice it went down. It was permanently closed right before the semester started. So sorry about that. If you need extra time to do Homework 0A, because there's a lot of setup, because we used to use this online website thing, so you didn't have to use Git and IntelliJ and all that. So if you need extra time, here you go. All right. Good. Okay, quick note, if you're watching the webcasts, I encourage you, if you're watching these videos, to try and pause and think about what I will do next. You'll probably learn more than just watching. Okay, just a note. Okay, so today we're going to go into more Java, and I should fix what year it is. Sorry about that. These are not the same slides, but they are the same month. Okay, you can just pretend that it's this year. These are newly updated, except for the year. What I'm going to do is I'm going to do, again, some live coding, but this time I'm going to use IntelliJ, which is the tool we're going to have you guys use. As we saw last time in Java, every function is associated with a class, and if we want to actually run a class, we have to make a main method. So let's pop over to IntelliJ. Let's make our font slightly bigger, and let's do some programming. So first we're going to start with the dog class, and in this dog class, we are going to have a make noise method. Actually, I'm going to move over slightly if I can. Let's make sure it works. Okay. More ergonomic. Okay, so I'm going to use this make noise. I'm going to write a make noise method, and what this is going to do is it's going to bark. Okay. Now, if we have this method and we try running this class, nothing will happen. There's no run button because the dog class has no main method. There's nothing that I can do, so that's not going to work. I could add a main method, and then I could say make noise. And if I did that, I would get bark. Here it is. But what I'm going to show you now is start thinking about how real Java programs are organized, mini classes interacting in some way. So I'm going to say the make noise method is not in the dog class, but is instead in dog launcher. So here, if I do this, I have make noise, but you'll see it's red underlined. And what it's complaining about is I don't know what make noise is. I don't have that method. So I have to go to the dog class and say, dog class, you go make the noise. And now that I call this dog launcher main, I get bark. If I were to go into the IntelliJ debugger, which you'll be learning about, I can step through the code, and I can see that when I click into this method, the first line of code is dog, make noise. Okay, I click in, and now I go to the dog class, and now I'm calling make noise. Okay, not a lot of depth there. But that's where we're starting. Okay, any questions about this so far? All right. Now, one of the things that we try and do when we write Java programs, or any programs at all, is we're trying to recapitulate features about the actual world. Like we build lists and sets and maps and customers and students and dogs and whatever else. And so here I have a couple of videos showing you that dogs are not all the same. Okay, here's one dog. It's really pleasing. All right, anyway, you can watch the whole thing later. And then there's other dogs that sound more like this. I believe. All right, so the point is we want to build classes that can do many things. Oh, I'm not? Okay, sorry, Internet. Thank you, thank you. We were too busy policing the room. Okay, here we go. Let's.
71 questions about this.
All right. Sorry, Zoom. Okay. Well, I'm not going to go into dog and cat debates today. So we could, in principle, create different dog classes for each different type of dog. Like that dog on the left was named Maya. But that's not going to work very well for real practice. So what we're going to do is take advantage of the fact that in Java, classes contain not just functions necessarily, but they can also contain data. So for example, this dog class can have a size variable. And so if I go over here to the dog class, I'm going to go in here and I'm going to say, dog, you now have properties. Okay, set that my user interface is misbehaving. Okay, interesting. I'm going to blame Zoom somehow. What on earth? Dog? Oh, I see, because it's still in the middle of running. That's why. Okay, so now I'm going to do public int, and I'm going to do weight in pounds. That's just the name I'm going to use. That's going to be the weight of the dog. And that's going to be a property that each dog has. Now in dog launcher, actually in dog, I'm going to change this make noise method. And I'm going to say if my weight in pounds is greater than 20, let's say, just arbitrarily. Okay, oh, that's fine. Then I'm going to do aru. Okay, nice sonorous aru sound. Else if weight in pounds is less than 10, then we'll do maybe more like a bark. And then else we'll just do a little yip noise. Actually, I'll do yip, 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 yip. Like the other dog we saw. Okay. Those are the properties. Based on this property of my dog, weight in pounds, I'm going to have different behavior. That's the idea. Now you'll notice that weight in pounds is in red, and it's yelling at me and saying, you can't see it very well on the screen, but I'll read it to you. Non-static field weight in pounds cannot be referenced from a static context. I'll explain more about this as we go, but the fix just for now is I'm going to delete the word static, and we'll revisit that static, why it exists or doesn't. So this is a different kind of function now. And once I take away the word static, I can access the weight in pounds. And then in dog launcher, I can adjust my code. Okay. So what I'm going to do next is I'm going to say dog, let's say Maya equals new dog. Maya dot weight in pounds equals 30. And then we can tell Maya to make noise. Okay. And I'll go over these steps again. But here if I run this code, I get back etc. And if I go down to 9 pounds, then I'll get, well, bark. Okay, that's interesting. That's not what I expected to happen. Greater than 10. Okay, so we got a yip, yip, yip. Okay. All right. So what we've done now is we've created a class that acts as a template for any dog out there that could ever exist. The class is a blueprint that all dog objects have to follow. They have to have a weight in pounds. I guess I'll rename it to size to match the lecture slides. One of the nice things about IntelliJ is it has a smart rename feature, unlike a plain text editor, where if I just type size here, it fixes the code everywhere. Okay? So here's what we've got. Okay? We've got size, weight in pounds, different ideas, different times. Okay? So this is my dog class. Now, if you know Python, the equivalent code in Python would look like this. It has an init method, right? Oh, oopsie, I skipped ahead. Never mind. Okay, there's one more thing I want to do, which is the dog launcher class. I'm a little rusty. The dog launcher class, it has an issue, which is that this is really awkward syntax to say, Maya, you're born. And what size is Maya when she's born? No idea. Then we set the size. That's just not how we usually do these things. Instead, we want the code to work like this. When Maya is born, when we create Maya, when we breathe life into Maya, we say, your size is 9. Okay, that's what we want to happen. So we'll go to the dog class, and now what we need to do is add a new thing to our class called a constructor. So public dog int s, I'll call it, and then I'll say size equals s, and this tells us, this is a constructor, it tells us how to make dogs. Okay? We could have done something else, like s times 5, would be kind of weird to do, or like s plus 3, but I'm just going to set size equal to s. Now, when I create Maya the dog and say make some noise, it works beautifully, and we don't have the awkward syntax of having to create sort of like a cosmic kind of ethereal dog and then set the size and then it does stuff. Okay. All right, any questions so far? So hopefully this feels kind of familiar from 61A. And if you want to see the equivalent 61A code, it looks like this. Okay. So we have a constructor or an init method. I don't know if they call them methods. I guess they just call them constructors also in Python. And works basically the same. Yeah. That is a great question. Yeah, so let's suppose the question was, can I say dog.make noise? So if I were to try such a thing, I can. Uh-oh, we're a little frozen. Okay, here we go. If I were to go dog.make noise, it will not work. In fact, what it'll tell me is non-static method cannot be referenced from a static context. And the way to think about this is that you're telling the idea of a dog, right? Like just the abstract, the platonic ideal of a dog, please make noise. But you can ask all you want. There's no specific dog to make noise. It's not going to work. You can't just say idea of a dog, make noise. And that's captured in the fact that this method is so-called non-static. If it were static, it would be something attached to the class itself. But because it lacks the static keyword, it's saying it's some specific dog. And we'll go over that in the next set of slides. Okay? So we can't say dog make noise. Yeah?
What happens if we make the make noise function static?
If we do that, if we say static again, now the method won't work because size isn't defined, because there's no specific dog in mind. And that's weird. We'll talk about it in great detail in just a moment. Yeah?
Were you able to overload the functions so they can be static or non-static?
You cannot. I don't believe you can have two functions, one static and non-static. You can have multiple functions of the same name like we saw last lecture with int and double arguments, but as far as I know, the Java language specification does not allow you to have static and non-static. I don't know why you want to do it anyway. Okay, so let's talk about some terminology here. This top variable up here, whether you call it weight in pounds or size, that's an instance variable, and you can have as many as you want. A dog can have an arbitrary number of properties, number of legs, number of tongues, or whatever else. Here we have a constructor, which is not a method. It's just another thing. And it tells you how to instantiate the class, how to make an instance of it. And here we have a non-static method. This is known also as an instance method. And the idea is that you don't want the word static. The word static should not exist if there's going to be a specific instance that is going to be used to invoke or call that method. So I'm saying, Maya, you make the noise. That means this should not be static. In other words, if the method needs to use my instance variables, then the method needs to be non-static. Okay. Now classes, as we saw, can have not just functions, but they can also have data. We added that size variable. And then, of course, classes can be instantiated as objects. We can say dog, let's make some specific dogs. So again, we make a single dog class, and then we create instances of the dog. And those instances in Java are sometimes called objects. Okay. And that class this is a blueprint that all dogs have. They all have the exact same properties. And that's different than some programming languages, like say MATLAB, where you can have an object where each instance has slightly different instance variables. In Java, they all have to be built exactly the same if they are of the same type. Okay? You can never add new instance variables to a dog. There's no way to do it in Java. They have to obey the blueprint exactly. Okay? So if, for example, I try to make a dog and say your name is Frank, we'll get a syntax error. Okay, it just can't happen. All right. A little more exciting terminology here. When I say dog, small dog, for example, in that case, what we're doing is we're declaring a dog variable. So we're saying that there is a place to put dogs. New dog 20 is the opposite. That is the creation. That's the breathing of life into the dog. Here we're only instantiating the dog, but we're not putting it anywhere. It exists, but we're not storing it in any variable. Here we do both instantiation and assignment on the same line. And here assignment means taking this dog and putting it somewhere. And we'll delve into exactly what the equal sign does next lecture. And then we have declaration, instantiation, and assignment on the same line. Now one note is that if you instantiate a dog that you don't put anywhere, this anonymous dog, it will get garbage collected, which sounds very bad. But basically the dog gets instantiated and then destroyed, because we didn't store it anywhere. Disturbing stuff. And then anytime we see the dot here, this dot notation, we're saying we want to use a method or a variable belonging to, in this case, huge dog. In other words, it's a member of the huge dog object. All right. Yes, please. And feel free to fire a question off at me. Yeah. There are no destructors. The garbage collector handles those. So it's one of the reasons I use Java in this class and not C++ to avoid memory management. Yeah. The third line here? It works because above here we've declared this variable. If we had not declared it, it would not work. Yeah. Say again? Yes, that's correct. Yeah. And it defines the weight because that's how we wrote the constructor. Here I can actually reach in and set the weight in pounds. That's fine. You're allowed to do that.
So now, like, the huge dog is now defined.
Yeah, the huge dog actually changes size when you do this piece of code. Yep. Yep. And by the way, homework 0B will give you a lot of practice with this sort of thing. Go ahead. Yeah. Oh yeah, question. I missed it. Oh, there you go. Thank you.
For the new keyword, do you always need to use that when you're instantiating a new object?
Right. So unlike Python, where you don't need a special word like new, in Java you do. So just be aware, Java's a little more verbose that you put the word new almost any time you make a new object. There's a couple of shorthands where you don't. Yeah. Yeah, if you don't put new, it'll just get confused and not know what you mean. Yeah. I think it's a syntax error if you just say dog20. But you'd have to double check. Great. All right. Let's suppose we want to make an array of objects, which are mentioned in homework 0. If you wanted to actually do this, you would use new to make 3 times to make an array of 2 dogs. First, you'd make an array of 2 dogs. And if you haven't seen this array syntax, it's in homework 0A, sorry. And then here we would say, so this right here creates 2 boxes where dogs can go. Then dog 0 equals new dog. This actually creates a dog and puts it in this left box. And this one creates a new dog in this position. And then you can tell a certain dog to make noise. Okay, so just minor trivia that might be useful to you later. All right? Oh, yeah.
For like arrays, do you have to explicitly state how large it is before you?
Yeah, arrays have a fixed size when they're created. That's important for Java being fast. Good. All right. So let's talk a little bit about static versus non-static members of classes. Oh, I should also say, by the way, the first 8 lectures of this class are kind of Java heavy. So if you're somebody who already knows Java, I think you'll still learn new things. After roughly lecture 8, we go into totally new territory. And we're not talking about sort of basic programming language stuff. And I would say even next lecture is where it gets super interesting. Right now, I just want to get our foundations built out, get some common terminology. So I think these 2 lectures in some ways are the most boring lectures of the semester, but they are also very important. Okay, let's talk about static versus non-static. So if we have a static method, like we had before, let me hide these controls, sorry, I should have done that earlier. If we have a method that we had before that was static, the way we invoke it, the way we call it, is we go to the class and we say dog class, you make noise, and in that case that would work, it would bark if that's how make noise was declared. If we have a non-static method, then we have to actually create a specific instance and then say, hey, Maya the dog, now you are the specific instance and you make the noise. And because this method is non-static, it'll work. Static, by the way, if you don't know the word well in English, it just means like unchanging, I think is the best way to think about it. Or permanent, or well, static in my mind. It just feels, it's in stasis. Okay? It has no momentum, no properties, it just is. So static methods, we invoke those, as I said, using the class name, instance methods using an instance name. And the basic idea, the difference between them is that static methods can't access my instance variables because there is no me. Okay, and we'll build some examples of such methods. So you might say, why do static methods even exist? It seems like less flexible. Well, one very natural example is that in Java there's a math class that has like a rounding function and a ceiling function and all that good stuff. And so if we say, math class, please round 5.6, it's just nice that that's the syntax and that we don't do something like create a new math object and then say, like, you're the math, and now you go round x. Like, the language could be made that way, but it's just not, it's not as nice. So the Java language designer said there exists a static keyword so that we can have methods that don't need instances associated with them. You don't need to make new math objects. Okay? Now sometimes classes can actually have a mix of static and non-static methods. So for example, I can go into my, that's interesting. So every time I come in here, it behaves a little funky. I can go into my dog class, and I could add a static method. I'll make one that compares two dogs and returns the larger of the two dogs. So I have dog A and dog B. It's supposed to return a dog. And we'll do it like this. If A.size is greater than B.size, then I'll return A, otherwise I'll return B. And this is a static method. And the way I'd use it, maybe you can think about this, especially if you're a webcast viewer. Let's imagine we have two dogs. Huge Greg. Okay, it's a very large dog. If I were to oh, wow, I like it. It's good. If I want to actually compare these dogs, Maya and huge Greg, what do I need to do here? So it's a static method of the dog class. Do what? Yeah, class name, right. So I'll say dog.maxDog. And we'll say larger. There you go. Okay, and once I do that, I can say larger dog, you make a noise. And since it's the bigger dog, we expect it to aroo. And indeed, huge Greg aroos. Okay. Questions about this? Yeah. Either one. You guys got to pick.
So for things in Python, we talked a little bit about like mutability and stuff. So when you're returning the larger dog, is that going to be a copy of the dog?
Mm-hmm.
Or is that going to be the same, like, is it
So I'll spoil it. We'll talk about this in lecture 3, but it's the actual dog, not a copy. And that'll be important to lecture 3. Go ahead, next.
And then my question was, in Python, I think we dealt with how objects can also call methods defined in the class. Can a particular instance of the dog class?
Right, so technically you could say larger dog.maxDog. Yes, you can, but if you look at it, it says, it's a warning. It says static member accessed via instance reference. So this usually I consider bad style. You can technically do it, but I don't think it's a good idea. If it's a static method, I say always use the class name, just for clarity. Yeah? That's a great question. So if maxDog is a static method, how can it access Maya and huge Greg's variables? Well, that's because in this class, it's asking for a specific instance's size. That's why. So we couldn't say if size greater than b.size. That gets confusing because I don't have a specific size. I'm the idea of a dog, but I can judge two different dogs. You can give me two dogs, and then I'll give you the answer. All right. Now we could actually, by the way, okay, actually you're overloading question. It is possible. I could do public dog, max dog. All right, yeah. All right, I actually already knew the answer. So you could do, for example, comparing myself to another dog. Okay? So I misspoke earlier. If I wanted to, I could do something like this. I could say if, and here I'm going to do something, you don't have to use the word this, but I'm doing it because it makes it more clear what I'm talking about. If this.size is greater than other dog.size, then I'll return this. Otherwise, I'll return other dog. I can actually delete this if I want. And Java, if you don't specify like self, it'll just infer that you mean yourself, for better or worse. So in Python, they really want you to be explicit about everything. This is a place where Java is a little, like, slightly sloppy. Here I'm comparing my size to another dog. Okay, yeah?
Like without this, if you have a size in your functions, in your method input, wouldn't that like
Yeah, like if I did that, then I'll run into some kind of trouble. Actually, no, then the this makes it clear which one it is. Yeah.
so like that's why you use the this.
Yeah, right. It's one reason to do it. Yeah. Is that your question? No. I generally like this, but you may not. Yeah. Your choice. Now, if I wanted to use this max dog, I'll say we use the non-static one. So we'll signal that we use that one. How do we make sure that how would we use this make noise method, the non-static one? What do you think? Oh, sorry. Let's go back to, well, I kind of spoiled it, didn't I? Okay, this is what we're doing. Oh, sorry. Okay. The text is too big on my screen. All right. How would I use the max dog function that's non-static? What could I do here? Yeah? There you go, right. And we could do it either way. So, Maya, please compare yourself to huge Greg. And that would be fine too. And both approaches are perfectly fine. And this says we use the non-static one, because when we called this function, I guess we'll use our debugger. When we called this function, if we step in, we find ourselves, oh, oopsie, wrong place. Sorry. Okay, so what I'm gonna do is run the code. It's gonna stop on this line. And when I click this button, it's gonna say where the code goes next. The next place it goes is into the max dog function that's non-static. All right. Okay. Any other thoughts? Should you have a static or a non-static max dog function? Your choice. All right. One more thing I'll mention is that static variables are something you can create. So I can, for example, go into the dog class and have a property that's common to all dogs. Okay, and then stop this. So I could do public static string binomen. I feel like I should know how to say that after doing this lecture so many times. But that'll be a common string that all dogs share. Okay, so that never changes here. It's going to be a constant that ideally that should never be changed. Now, technically, this code you can alter this binomen in code elsewhere, but I'm just going to throw out there that it's just a very bad practice. You will have no temptation to do this for a while, but in project 3, I'm going to remind you, please don't do this. Don't ever have a static variable that changes. There's almost never any reason to do it. Understanding why it's dangerous is too hard to talk about right now, but we'll talk about it when we get to project 3. Okay. All right. So a class can have a mix of these static and non-static members. We have seen how you can have static methods and non-static methods. We can have static variables and non-static variables. I'm going to say for the most part, don't use static variables almost ever, but there'll be some reasons to do it occasionally. I'll say that technically, someone asked earlier, can you use an instance name to access a static member? Yes, but I'd say don't do it. And the other way is not possible. I could not say dog.makeNoise because there is no dog to make noise if it's a non-static method. Okay? Yeah?
Can I make the static string constant?
You can make it constant by adding the word final, yes. Yeah. All right. Oh, yeah, go ahead. Say again? Yeah, sure. And then someone over there had a question. The static keyword means that it is a universal property shared by the whole class. Final means it can never change, and those are somewhat different, right? So static, despite the fact that I said it means unchanging earlier, final is maybe the better word. Static is a bit of a slippery concept. Okay. I'm advancing even if you're not totally ready, sorry. All right. Right, yes they are. And there's also a repository with all the code. Or I'll update it right after lecture. All right, let's talk about lists. So in programming languages, a list is an ordered sequence of objects, which often the shorthand is a comma-separated list of values in brackets. And lists support operations according to whatever the authors of the programming language decided to include. So for example, maybe we want to append items, like add 18 to this list. We could retrieve items by index. We could remove items by index or value. Those are all things that different lists and different languages support. So Python lists, as you know, have a really simple syntax. I create a list with closed brackets. That's the empty string literal. And then I can append A, B, and C. And when I print out the list, I get A, B, and C. Okay? So I'm going to try doing this in IntelliJ, and we'll see what happens. So we'll go to our list demo. Okay, we're going to say L equals bracket, and it's going to say immediately, I don't know what that means. L dot append A. Okay, L dot append B, and we'll add better stuff in a sec. This is where we're starting. Okay, and we'll print out L. And let me make the text slightly bigger too. Okay, so this is not quite right. What I need to do is actually say list L, and then I'm going to say instead of brackets, I'm going to say new list. And that gets us a little closer. Now we have a few problems. One of them is that list isn't declared. And there's a really nice keyboard shortcut that you can see here being yelled at me that it wants me to import something. So I'm going to click here and say import. I click that line and I get import java.util list. And now list will work fine. Except for one more problem, which is that lists cannot be instantiated. So a list is abstract. Talk about that in a moment. But I need to actually pick a type of list. So I'm going to say an array-based list. Okay? That's not declared or imported, so I'll say import. And now my code is pretty close to working. Okay? Instead of append, it's called add. And now at this point, my code will actually work. There's still some warnings here. You can see these texts looking a little funky. We'll get to that. But now when I run this code, it works. Okay? So I've got a list here which is A, B, C. So again, Java a little more verbose than Python, but nothing so crazy. List L equals new array list, add A, B, and C, print it out. Okay. So I'll skip forward slightly. Okay, so that's just the slides version of what we just did live. And so let's think about like what's really like most interesting about the differences between these two approaches. And I'll take questions or suggestions after we get this next little section done. So one of the really interesting things about Java is that it makes a distinction between an abstract data type and a specific implementation of that data type. So there's many different types of lists in Java, and that's unlike Python, where there's just one. I mean, that uses the basic syntax. There are many types of lists in Python as well. But it's a more visible concept in Java. If we look at lists, there's a number of different types of lists, like array list, linked list. They also, I think a vector is a type of list, and so forth. And they all have the same operations, but they have different implementations under the hood. Okay? So I can, for example, change my code. Instead of using array list, I can say linked list. I'll do an import of that. Okay. I'm not going to tell you why you would ever do that. I'm just going to say that it's possible. I could say, I want a linked list instead. And that code's going to behave exactly the same way. I'm still going to get A, B, C. It just happens to be using a different technique under the hood to make the list work. Okay? So that's one thing that I find really interesting about Java's approach. So in Python, I mean, a list is a list is a list, like at least the key one that has the first class nice syntax. And you as a programmer, you're not thinking at all about what type of list it is. In Java, you have to know. You have to say, I want an array-based list. By the way, the Python list is also an array list, and we'll get to that in about 4 lectures. But in Java, you have to decide which kind of list you want. Okay, so it's a little lower level. So there's a term out there in programming languages, which is the idea of an abstract data type. So here, list, there are many types of lists, and every list is guaranteed to have all of these operations. Let me go back to our page. So every list, oopsie. So every list out there, it has these methods. It has add all, clear, contains all, equals get, hashcode, index of, is empty, iterator, etc. Okay? So here's a question for you. Why does Java have many different concrete implementations of a list? Like, why might this be the case? Yeah? Well, I wouldn't say it's so much not repeating yourself, because, I mean, in Python, you don't repeat yourself by all using the same list by default, yeah? Yeah, they have different properties. So maybe that sometimes some list is better suited for your other purposes. Okay. So they may have better performance in certain cases, is maybe one way, because they have these different properties. So linked lists, for example, are really fast at removing the front item, but array lists are slow. to remove the front item. So if you actually time the operation on your computer, you'll see linked lists can pop items off the front of the list very quickly. So if you have a specific use case where you want to build a list where you want the delete front to be very fast, you use a linked list. There's also other examples, like sometimes there's types of lists that have extra operations on top. So for example, there's a push and a pop operation in the stack implementation of a list. But it's a little bit advanced, and we'll get to that sort of idea later. Okay, any questions so far? Yeah?
Wait, can a do array lists have like, wait, can you remove something from the start of an array list very quickly or no?
You cannot. So in a Java array list, if you delete something from the front, it's going to be, it has to move everything over.
What about the back?
The back is fast for an array list. This is a little bit ahead of our schedule, though, to discuss. But by the end of the first 5 weeks, you'll know exactly why those two things are true. Yeah?
Don't you have to specify the type of the list?
We did, right? Oh, and the type of the list. Oh, yeah. No, you don't. It worked. Look, you know more Java than we have got to so far. We will fix that soon, though. Yeah. In fact, there's a warning here. It's telling us raw use of parameterized class list. Okay, I'll talk about that. Okay. So building off your question, in Java, we can build lists like this, but we'll see that it gets a little awkward. So in Python, we get back items using bracket notation, like, hey, list, give me back element 0. In Java, if we want to do that, we use the get operation. Not like the tool you guys are using, but just the word get. Okay, so l.get0 will get back the letter A. But where we'll run into trouble and where things get really awkward is what happens if we try to do string x equals l get 0. So let's go try it. Okay, so we have a list here. Okay, I don't know why I have to do this in this room with the setup. Okay, if we go back to list demo, if I say l.get0, I get back something. And I know it's a string. If I say string s equals l.get0, I have an error. And the error is, you tried to give me an object, but I want a string. Okay? So I can't get, like, I can print it out just fine, right? The print method is happy to take whatever you give it and actually print it out. But let's say I try and assign it to a variable. So here's the A, like it worked. But if I try to actually assign it, it's not going to work with the way we've set it up so far. So we need to fix this. Okay. Now, in the Java 4.0 days, quite a while ago, this was how code worked. And there was like an extra special thing you had to do called a cast. I'm not going to explain it now or ever. Instead, I am going to show you what happened in 2005. So in 2005, the Java designers added a new capability to the language. Java had already been pretty big. It had been running successfully for about a decade. But they decided they wanted something a little nicer, which is the ability, sorry, I have to keep doing that, the ability to specify what goes in your list. So there's two things I'm going to do. First, I'm going to add this little like curly braces and put string on the left-hand side. And then on the right-hand side, I'm going to add this empty braces. Now that I've done that, I've modernized my code, and it will work with no warnings. And I can assign this variable just fine. Okay. Questions about this? It's just like magic syntax for now. Questions or thoughts? Okay, yeah. Yeah, sure. If I didn't do this, I could add strings and integers and everything into the same list, and that would technically work. Yeah. Okay, good. Yeah. And you have one?
Yeah, so if we didn't specify with string, can we just say object s, you said, equals l?
Yeah, we sure could do that as well. That would have worked as well, but beyond the scope of the syntax we've seen so far. Okay. Now, one thing that this does for us is now that we've used this notation, my list can only contain strings. And I would say this is actually a really nice thing. Okay? So going from Java 4 to Java 5 lists meant that lists can no longer have multiple types. So why might this be a good thing? Give me some thoughts. Yeah. It can be faster, yeah. So there's predictable sizes for objects, so it could potentially be faster. Other thoughts? Yeah?
Easier to sort.
Easier to sort. In what way?
For example, if you want to get a function with just
Oh, right. It's kind of hard to imagine what it would mean to sort an array of multiple types. Sure. Okay, yeah. Less error types, right. There's no chance that you're going to think you have a string, but actually you have an integer or whatever. And the kind of building on that, it's just you have a clearer sense of what you have. Your code's easier to reason about, okay? So the way I think about it is it means there's just less freedom. Like when you say it's a list of strings, it's a list of strings, okay? And that to me is a big deal. You're putting constraints on yourself. And when I think about what makes programming hard, it's actually putting constraints that makes programming possible. Freedom gives you complexity, like allowing yourself to use static variables or whatever. And complexity is hard to fit in your brain. Right? It's just very hard to keep track of a complicated program. And so Java has lots of these features that basically they handcuff you. And they force you to only, say, have strings in your list. And that's a recurring theme in this class. That over and over, Java lets you set constraints on yourself, which is a good thing. Okay. Let's talk a bit about arrays. So we saw arrays in homework 0A if you've done it. And if you haven't, that's OK. But half of the students in class have finished it. If you haven't, you get working on it. So Java has a special type of collection called an array. Okay, so it has, unlike lists or whatever, which are kind of verbose, it has that special bracket syntax. And you could think of it as a restricted version of the list abstract data type. So arrays, you have to actually say the size when the array is created, and that size never changes. All items have to be of the same type. It has no methods, so there's no like get me the 5th item or tell me the max or anything built in. All it has is a bracket notation for accessing specific items and also setting them. But there's no special methods for, like, say, max or sorted or anything like that. Okay? Now, there's nothing like this in Python. Python does not have a type that you can access that is array-like with these fixed bounds. So Java, this is a new type that gives you like even tighter constraints. So why do you think Java has lists and arrays? You can think of an array like a list, but with fewer features. It has to be all the same type. It has no methods. The size is fixed. Yeah? Yeah, you can go through an array really easily. And when you take 61C, you get a deeper sense of what that means. Because everything is the exact same, it's very fast to calculate how to get the whateverth item. Okay? It's a good thought. Yeah, it's the main one, I'd say. So they're more performant. Reading and writing them is faster. You use less memory. That's the main reason. And when we later, in about 2 weeks, build our own lists using an array, you'll understand how the Python array is built in C. Okay, because Python, well, typically Python compiler interpreters are built in C. All right. Why is an array faster, though, exactly? That's actually a 61C topic. Why do you think Java favors arrays over lists? Like lists, I had to do all this stuff. Right? I had to it's like crufty. Whereas the array is like the special syntax. It has the special bracket syntax. It doesn't require any imports. What do you think? Yeah?
Lists are newer.
Say again?
Lists are newer.
Lists are newer. Oh, that's a good answer. I like that. Yeah? I don't know if lists are in the first Java or not. Yeah? Yeah, lists are built on top of the array. That's another good answer. Okay, I don't even know what I said. Yeah, oh yeah, that was a good answer too. I would say that Java is a language which is built for performance, whereas Python's built to be beautiful, simple, and elegant. So Java, it has the performant thing as its first class object, but I think your other answers out there seem to be reasonable to me. Now when you take 61C, I alluded to the C programming language. C is an even more performant language. It's even more oriented around performance, but it's even harder to write the code, because you're acting at a kind of lower level. So you're going to do kind of a step as you go from 61A to B to C if you're someone who's going to take C, where you go from beautiful and elegant to more performant and having to think a little bit more about memory and this low-level stuff. And then in 61C, you'll be very close to the hardware, and you'll see if you have all that control, one, why it's painful, but two, how it is fast. All right. I disagree that C++ is more elegant than Java, but C++, I'll say, I mean, you could argue it is, but one thing that Java does for you is the memory management. So one thing you won't have to do in our class is have to deal with whenever you're deleting objects. What?
C is elegant for its simplicity. C++ is a mess of code built on top of C.
C++ is, I don't know. I haven't written any C++ in about 15 years, though. Not much. What I can tell you is that it's a harder language to learn how to build arrays in, array lists in. All right, maps. I got one more little topic for you. You guys know dictionaries? Simmer down. No mutiny around C++. So in programming languages, a map is not just a list of things. It's a collection of key value pairs, and each key is guaranteed to be unique. In Python, they're called dictionaries. They're also called associative arrays in theoretical computer science. And for some reason, when I taught at Princeton, their class called it a symbol table. So an example would be I map alpha to the first letter of the Greek alphabet, potato to a starchy edible plant. You've seen these before in Python. I just want to show you the same thing. I'm actually not going to do the IntelliJ version. But let me show you the same thing in Java. So if I want to make a map, it's not going to be this nice first-class syntax. Instead, it's going to look something like this. I create a map which goes from some type to some type. So in this case, from string to string. And then I need to pick a specific type of map. In this case, I've chosen tree map, but there's also another very popular one called hash map. And they have trade-offs. And when we get later to the tree part of the class, we'll understand the trade-offs between the tree map and when we talk about hash tables, the hash map. To associate the word meow with cat, we put dog, comma, woof. It's kind of ugly. I like the Python syntax more. Python is more elegant and beautiful. But with what we have in Java, this is the syntax that we get. And then lastly, we use the get method to get back the item associated with cat. Okay, and so homework 0B gives you a chance to practice with that. The key thing I want to highlight, if you're kind of zoning out, is that with a map, you're actually specifying both types. So it would be from string to integer, or a string to integer, or integer to string, or whatever else. Okay, so to summarize what we got so far. Okay, two more things. So one thing I want to say is that the most common map implementations are the tree map and the hash map. And just like with a Python, like if you want to know what Python does, Python uses an array list, and Python uses a hash map. And so what we're going to do in the next 5 lectures or so is really understand linked lists and array lists. And then after the midterm, we'll start talking about tree maps and hash maps after we have a little more machinery under our belts. The last thing I want to say is homework 0B is available. It's short like 0A, so get started on that. I have a checklist of all the things to do, and if you join late, make sure to check out this link. Thank you, everybody. Bye. All right. If you would like to debate C++ versus Java, please join us now at the front.
C++ Java.